All right, evaluate each trigonometric function of angle A, and angle A is right here. And then it tells me that the side adjacent to angle A has a length of 6. So here's the side adjacent. And then it says the side opposite angle A has length of 16. That's this side here, which means I have a third side right here, which would be the hypotenuse, and we don't know what that is. So I am going to start with figuring out what that side is, because in order to get the answers to all these, I need opposite, adjacent, and hypotenuse. So a squared plus b squared equals c squared. And remember that your hypotenuse is the c, and then the other two are your legs. They call them the legs. So this is going to be 6 squared plus 16 squared equals c squared. 6 squared is 36, and 16 squared is 256, and 256 plus 36 is 292. And then at this point, when you go to take the square root of both sides, the square root cancels out the square and leaves you with c, but 292 is not a perfect square. And it does say it wants, right here, find exact answers, which means leave it in radical form. Now, 292 is not a perfect square, so I have to start looking for factors of 292 that are perfect squares. And I tried the smallest perfect square is the number 4, and 4 is a factor of 292 73 times. 73 cannot be simplified any further. The square root of 4 is a 2. I cannot simplify the square root of 73, so that just stays there like that. And so the hypotenuse is 2 times the square root of 73. And now I have to remember that sine, cosine, and tangent, if you remember the old saying, so, ka, to, ah. I don't know why I said it like that. But when you go to do sine, S is for sine, and then it's opposite over hypotenuse. So my sine is going to be the, remember the orange is opposite and the green is adjacent. So opposite is 16, and hypotenuse, because it's OH, is the 2 square roots of 73. However, I can simplify this because this 2, which is not under the radical, will divide into that 16 8 times. So I'm going to have 8 over, why did I write 32? I have no idea. It was 73, April. Starting to lose it, man. The square root is 73. And I've already checked my answers because I wasn't sure if Mobius wanted me to rationalize that, but it doesn't. So this is my sine, answer to the sine of A. And then we're going to go to the cosine, which is opposite over hypotenuse. So cosine of A is, did I say adjacent over hypotenuse? So adjacent is green, and green is 6 over 2 times the square root, I almost did it again, of 73. And I can do the same thing here. This 2 goes into that 6 3 times. So this is 3 over the square root of 73. So that is my cosine. And then last I've got the tangent, and tangent is opposite over adjacent. And so the opposite is the 16 and the adjacent is the 6, but that can be reduced down to 8/3, and that is the answer to tangent. And now for the rest of these, those would be the reciprocals. You just have to remember how they pair up. Secant actually goes with the cosine. So I have to take the cosine, which is this one, and to get the secant of A, it's just going to be the reciprocal of that. So it will be the square root of 73 over 3. And then the I don't know, got lots of greens here, and blues and purple. How about, I don't know, dark blue. The cosecant goes with sine, so this one's sine, so cosecant of A is going to be the square root of 73 over 8. And then the last one, which I do not know why that happens. Cotangent. We got the cotangent here, and cotangent obviously goes with tangent, which is the blue one. So the tangent, the cotangent of A would be 3 over 8. Okay, so now I'm going to do a split screen here. And there's that. And you can see that my answers are for sine, it was 8 over the square root of 73. Cosine is in green, 3 over the square root of 73. Tangent is 8/3. And then secant was the red one, square root of 73 over 3. Cosecant was up here in this blue, square root of 73 over 8. And cotangent here in green is 3/8. And they're all in green, boxes. So I got them all right.